In this video, we're going to go back to the PhET simulation of the skate park and see what effect it has when we add in the friction.
So while you're doing this, I want you to think about, once again, how does the energy shift as the skateboarder goes down the ramp? What happens to the kinetic energy at the bottom compared to when we had no friction, and why? And what does this do to the skateboarder's final speed? So you'll need to go back to the PhET simulation, and this time, instead of clicking on intro, you're going to need to click on friction, and maybe a second time to go into that. Then, like before, you'll choose the ramp shape, and you are going to choose the bar chart, or bar graph, so that you get that over here. Then you're going to put the friction onto lots. As before, you may find it easier to switch on to slow motion and then drag the skateboarder up to the top and release them and watch what happens. So remember that you were going to think about how does the energy shift as the skateboarder goes down the ramp? What happens to the kinetic energy at the bottom compared to when we had no friction? And why do you think that is? And what does this do to the skateboarder's final speed? Obviously, you can spend a little bit of time on this and you can adjust back using this slider to no friction to help you compare if you can't remember what you did earlier. So pause the video now and go away and have a try at that. What you will have hopefully observed is that whenever friction does work, some energy will be transferred into the thermal, sometimes called internal store of the object and surroundings. I think this is an important point which you should include in your notes. Once you've done that, we can go back to thinking about how this might appear in an exam question. So if we return to the minor question that we were doing earlier, and now think about what can you say about the miner's final speed compared to what you calculated and why. Thinking about what you saw with the skateboarder and where some of the energy ended up rather than in the kinetics energy of the skateboarder, how would that apply to the miner and what would happen to their actual speed compared to the one that we calculated? Pause the video and have a think about this. Hopefully you've realised that their final speed will be lower because friction has done work, so some energy is transferred into the thermal store of the miner and the surroundings. Therefore, the miner ends up with less kinetic energy than we've assumed, and therefore they will have a lower speed because instead of all the gravitational potential energy being transferred into kinetic energy, some has instead gone into the thermal store of the miner and the surroundings. Okay, this completes our look at a typical example of using conservation of energy calculation, where we've done the calculation, ignoring friction, air resistance, things like that, and then thought about afterwards what effect those might have on the values that we have calculated.